Now we learn about variables. Variables are how we sort of build a memory for Python. The same memory that we wipe when we go to kernel and press restart. So maybe you remember x from your algebra days. X doesn't mean anything in Python for starters. If I run this second code block first, I'll get an error because I haven't done anything. X is not defined. X is not defined. We read our error messages and we get little hints about what's going wrong. That's not very profound when we only have literally one letter typed into a code block. But as your code blocks get bigger, as they do more things, it's useful to get little hints from Python, it telling you what it thinks is the matter. We can define x with the equals sign. And now, nothing happened. We didn't get any output because we didn't print anything. We assigned something. We assigned something to x, and it quietly accepted that new value. If we want to see what's in x now we can run the code. This is what I mean when I say Python has a memory. Python knows things. Python now knows that x equals 6. If I was to go to kernel and hit restart and run this code again, x would have been forgotten until I run x equals 6 again, and then I run my code, and then I get what I wanted. We can treat x like any number. Multiply it by 2 is going to give us 12. We can come with other variable names and use them just in the same way we use numbers in increasingly complex expressions. 2 times whatever w is 4, minus 1 times whatever z is 2. What Python's actually doing here is it sees this line and it says, okay, 4 equals w, I get that. I'm going to remember that. Then it gets to the next line. Oh, okay, whenever I see z, I should just think 2. I'm going to remember that. End of line. Now I'm going to go to the next line. It gets to this last line. And it says, okay, there's a lot there. I'm going to take this one thing at a time. What's there that's really not basic? Well, this open parentheses, that's pretty basic. That I get. This 2, yeah, I know what 2 is. I've seen 2 before. Spaces, I'm pretty open about spaces. I can handle spaces. That doesn't mean a lot to me. It's really going like character by character. Asterisk, yeah, that means multiplication. I already know this. Space, W, oh wait, W, huh. That's not basic to me. Let me check my memory. Oh yeah, that's 2. So I'm not going to try to remember everything. I'm just going to, 4. I'm not going to try to remember everything. I'm just going to replace this this W with 4. Now I'm going to keep going. Close parentheses, I know that. All this stuff I know. Da. Oh wait, Z, yeah. No, I don't recognize that off the bat. Let me check my memory. Oh yeah, 2. So I don't have to remember what Z is. I'm just going to replace the Z that's there with 2. Okay, I think I get everything on this line, so I'm just going to run it now. I'm going to do these operations. I'm going to go back to the beginning, actually, because I know that whenever I see parentheses, that's a bunch of stuff I can make smaller. So this 2 times 4, that's the same as 8, so I'm just going to do that. I'm going to proceed along. This 1 times 2, that's just the same as 2. I'm going to do that. And 2 in parentheses, that's the same as 2. And 8 in parentheses, that's the same as 8. Well, now I'm just down 8 minus 2. And that's 6. So 6 ends up being our final output. It took a lot of steps, but they happened really, really, really fast. So we didn't see any of that. We just saw it do this high-level thing, this 2 times W minus 1 times Z. So I've given you very basic variable names, but we can do more complex variable names. All of these in this block are valid variable names. And when I run this code, I can type in any of those things and get the value assigned. You see that in this case, we have magic sub number. I'm going to call the underscore sub. You can see here we have capital letters. That sort of makes things more readable. It doesn't mean anything. They don't have to mean anything at all. These are all very valid, sort of valid ways that you're going to see out in the world of naming a variable such as my name. You can have my name all lowercase, my name with some caps, with all caps, with underscore, all kinds of things. I'll run this, and my name is Ursula. These were all different from each other. All these different my names were variants. So capital letters signify a different my name than lowercase. Just like peoples whose names are things. What's a person whose name's a thing? Dirk. A dirk is a name, and it's a kind of a weapon. So lowercase d Dirk is a different kind of thing than uppercase D Dirk in English and in Python. There are rules to variable names. You don't really have to memorize these, but run them through, and it'll give you a sense of what's acceptable. I'm going to check in the examples that you've internalized these messages, and that way in the future, if you get some error message, you can make really sure that your variable names are good. No special characters. Kind of in general, your good rule of thumb: keep it to uppercase letters, lowercase letters, numbers, and underscores. You'll see a lot of underscores, which is why I call it sub. I say it a lot. Another thing to know is you're not allowed, there's sort of special reserved words. They're always going to appear in green in your code. You can't name a variable true or false because true and false are things in Python that already mean something. You can't define a variable called global or a variable called continue or not or in or from. You can't do that. Those words are already taken. You'll sort of, maybe you'll make this mistake every now and then, but it's a pretty rare mistake to make, especially once you learn more of Python, more of what these reserved R's are and what reserved words are and what they do. By the end of the class, you'll have used plenty of these. What I'm going to recommend is develop some conditions. Decide what kind of person you are. Am I an underscores person or a sentence case type of person or a sentence case except the first letter type of person? A lot of people are that type of person. I'm not going to be consistent in this class because I want to expose you to a variety of things, but you should sort of pick one in your own code just for yourself. What looks the best, what's clearest to you, what speaks to you, and what's not too much typing. This is a great time to talk about good and bad variable names. You can name your variables anything, but you probably shouldn't choose from all possible things. I have here code that gives me 1 plus 2. What's 1 plus 2? Variable 1 plus variable 2, what do they equal? You'd hope 3, but if I run this, they equal 2. Of course they equal 2. I was reasonable. I assigned the variable TWO, those letters, I assigned them the value 2, like you'd hope. But this variable ONE, I assigned it the value 0. So 1 gets replaced with 0 when Python checks its memory, and 0 plus 2 is 2. I'm going to go ahead and say that 0, ONE was a bad variable name for the thing I wanted to assign 0 to. I probably should have named it 0. You can confuse yourself and mislead yourself. There's a little bit of an art to picking decent variable names, but at the basic, try not to use X too much. This gives you just no clue at all about what your variable is, and it certainly doesn't help you. Your variable should mean something. X doesn't mean a lot to me. Let's say that 20, I'm doing some calculation to calculate someone's age or birthday, and 20 is their age. I don't want to name that X. I don't want to name it var, short for variable. You'll see plenty of that. I don't want to name it a variable. That doesn't help. It's not abbreviated, but I don't know what a variable is. It's not an age. I don't want it to be number. Like I know 20 is a number, but it's not. That's still not what 20 means. 20 means how old a person is. So here's some good names. Age is a good name for 20. Number of candles on your birthday cake. That could be it. Or candles generally. Those are, decent. They're a little more descriptive. They give me a little bit more to go on. The number 20 could possibly refer to a person's age, to a person and their age, to how old somebody is. We learned a little bit about output, and we saw very briefly when you assign a variable, basically when you use the equal sign, there's no output. That sounds, again, kind of in the weeds, a little nitty-gritty. It's just something you have to file in your I know this even though I don't want to know this kind of category. Things we memorize for memorization's sake. When I run math.e, I'm going to get an output, this output right here. When I assign math.e, I'm not. A variable now exists. It didn't exist before, so something happened, but there was no output because I didn't print anything. And Python didn't want to do me the favor of printing the assignment. If I really badly want to assign a variable and then double check that it means what I think it means, I can do the assignment and then I can put print afterwards. There we are, and it means just what we'd have hoped it means. Okay, persistence across code blocks. What do I mean by that? Well, magic number means something. We've assigned it. But we haven't defined unlucky number anywhere. Okay, so we should get an error when we run this. That's fine. So the important thing to remember is we defined magic number way, way, way up there, and it still runs. And if we type magic number here, so it still works. So these code blocks, they seem separate from each other, but they're all sort of speaking to one memory, that same memory that we wipe when we go to kernel.restart. And when we go to kernel.restart, our notebook will still be there, but all these variable assignments, all that memory of anything that happened when we ran a code block, anything that should be in Python's memory, all these variable names get wiped and we can start from scratch. If you do kernel restart and you want magic number to work, you're going to have to run way up there, whatever code block defined magic number. There is one FYI before we move on. That error that we produced, unlucky number, we could of course make it go away by defining unlucky number. We could also make it go away by deleting it. That's fine. Whatever you do, never submit a notebook to me. If you want credit for it, never submit it if there's errors anywhere. Always make sure if I tell you to produce an error, that you undo the code that produces that error one way or another, that you either fix the error or just delete the code. Whatever you have to do, you'll only get partial credit if you submit a notebook with some errors.